Hello learners, welcome to Unit 4 in the course Introduction to Abstract Algebra. In Unit 3, we look at algebra of numbers, where we covered very important concepts in algebra, such as prime numbers, fundamental theorem of arithmetic, and also don't forget about the modular arithmetic as well as the division algorithm. In this Unit 4, we are looking at rational and irrational numbers, real numbers. We also cover topics such as upper and lower bounds, and then we also look at continued fractions, either finite or infinite. I am Munkaila Dasmani, your course instructor for this course. In this session 1 of Unit 4, we are looking at rational and irrational numbers. Rational and irrational numbers. Thank you. Session objectives. By the end of this session, you should be able to state the properties of rational and irrational numbers. You should be able to state the relationship between rational numbers and real numbers. Explain why the set of rational numbers forms a third. And then you should also be able to express the same rational number in different ways. Okay, definition of rational numbers. Any number of the form P on Q, where P and Q are both integers, and then Q must not be equal to 0. So the question is, guess what will happen when Q is equal to 0? What will happen? So when I have a number like 1 on 2, the usual half, we can say that it's in the form of P on Q. Minus 7 on 1, what do you think? Still P on Q, rational number. And when I have 22 and 7, you can also see it's a rational number. So guys, if I have two rational numbers, A on B equals to C on D, then I can say that AD equals BC. And I think you completely agree with me like that, and that is a rational number. Repeating non-terminating decimals are also rational numbers. So now when we have a non-terminating decimal such as A on B, then we can say that this is also a rational number. Let's look at illustrations. Express 0.123 in the form A on B, where 1, 2, 3 terminates. So I have my list 0.123. So the 1, 2, 3 is terminating. You want to express this as a decimal. So you can see that let the 0.123 equals to x. Now when this one is equals to x, what can we say? If I call this equation 1, then I'm going to multiply equation 1 by 100. So that I'll remove the 1, 2, 3, the terminating parts. So I get 1, 2, 3, because keep on terminating, equals 100x. I call this equation 2. So finding the difference between the two equations, actually equation 2 minus 1, what do you get? So you get 999x equals 123. So in that instant, you can solve for x, and x will be equals to 123 out of 999. Okay, so if you express this in terms of P on Q, let's look at the next illustration. You want to express 0.57 in the form A on B as usual. So you let's say let x equals 0.57. The 57 terminates. So when I multiply this equation 1 by, let's say, 100 in order to take away the terminating part to be a whole part, so I get 100x equals 57 points, the terminating part. So I call this equation 2. Then what do we do? Let's find the difference between the two equations. So that's 99x will be equals to 57, and then I therefore solve for my x, and my x will be 57 out of 99. Okay, so very interesting. you can do more. Now I want to prove that square root of 2 is irrational. How do you prove that square root of 2 is irrational? So to prove this one, we assume to the contrary that square root of 2 is irrational. So if square root of 2 is rational, then we can say that if square root of 2 is equals p on q, that's the rational, then how do you see? Once we get that, then we can say let's square both sides. You take the square of both sides, you take away the root, so I get mine to be equivalent to be equal to p square or divided by q square. And I think you agree with me. So when I have this one, what can you see? So you can see that 2q square will be equals to p square, and that's fine. 2q square equals to p square, and then you can see from here that the 2q square is actually even, and that implies that p square is also even. And once p square is even, then p is also even. This means that there are some k, so since p is even, there are some k such that p equals to 2k. Great. And where is k? And k is a member of Z. K is a member of Z. And the reason is that 2q square is even, and it follows that p square is even. And once p square is even, it means that it can be written as p equals 2k. P equals 2k. So now let's start using the p equals 2k into 2q square equals 2 p square. So I get 2q square equals, then I put 2k square there, so I get 4k square. So once I get this one, implies that I can divide through by 2, q square equals k square. So once q square equals k square, 2k square, because the 2 balance there. Let me clean that. Okay. So that implies that q square equals 2k square. And what is happening? Since 2k square is also even, it follows that q square is also even, then q is also even. Once q square is evening, then q is also evening. And this is contradiction. Because the C or GCD of P and Q will be equals to 1. Therefore, we proved for that. Great. So we look for the next example. We want to prove that the cube root of 4 is irrational. So you use the same assumption we've just done, and then you arrive at a very interesting answer. So here you let we are proving. So you let the cube root of 4 equals p on q by an assumption that cube root of 4 is a rational number. So you do the same assumption and then you prove for that. So you get the GCD of PQ equals to 1, and that is contradiction. So then it's proofs. Great. So let's look at the next example. So go ahead for this proof. This is in your course material. We want to prove that square root of 2 plus square root of 3 is irrational. Okay, so the same contradiction proves. So let's square root of 2 plus square root of 3 equals p1 q. Here it means that we are assuming that it is a rational number. And then what do? You square both sides, then you proceed. The same principle, just squaring both sides and then you proceed. That is square root of 2 plus square root of 3 you squared equals p1 q or squared. Then you proceed in this process. At the end of the day, you get the proof to be irrational. Great. So go ahead, and this is so simple, and I've given you all the necessary steps or the necessary guidelines. Great.